So this week we're gonna talk a little bit about remote access and VPNs. I think this is such an important area now post-COVID. Um, and because of COVID, I think that we're more comfortable as a user with remote access and virtual private network. But from an administrator or a technician standpoint, you have to, dive a little deeper and get a better understanding. So, some of these protocols you've seen before from the prior chapters, or even in security courses. So we would go through them briefly and then answer some of the questions. The assignments are short today. So, okay. So the first section talks about remote administration protocols. These are protocols that are used to connect to systems. It doesn't necessarily have to be your local system. We would use these top two protocols, especially when we're configuring routers, switches, security appliance, anything that you using a terminal to connect to a network system, for example. So you have used PuTTY before, right? When we attempted the other lab, you've seen how that would be used connecting to a Cisco device, like a router or a switch. So Telnet has been around for a long time. This is used to directly connect to a system. It could be a computer, it could be another device. But Telnet, everything is in plain text. So we normally recommend turning this port off in security because if you leave that on, someone can connect to your system and they can modify things. And so that will be another way for them to get into the system. But Telnet was the traditional way that we can connect to the remote host. Nowadays, for example, if I want to connect to my Raspberry Pi with my laptop, and my Raspberry Pi is connected to my wireless network, I can use SSH. And Secure Shell, using encryption or cryptography, it allows you to be able to access the system. And we can do the same thing with routers or switches using SSH, right? With SSH, it uses PKI, which is public key infrastructure. Bless you. That means that you have to generate the keys and you need to use the keys in order to access the system. Now, in security, we talk about, encryption is great, but how do you protect your keys, right? Where do you store your keys? How good is your key? So when you're using SSH, when you're generating your keys, just make sure that you properly protect your keys. And we would use SSH a lot, and it uses port 22. Always remember that Telnet is one number higher than SSH. That's how I remember. And then for secure FTP, it piggybacks on SSH, so it uses the same port, right? That's why you have that encryption in addition to file transfer protocol. Now, for Windows environment, not necessarily absolutely Windows, but this is common in Microsoft OS. You would see remote desktop protocol. So for example, if I have an instance, which is a virtual machine on my Azure cloud, right? I spin that up and I turn that on. In order to connect to it, to configure it. So for example, you know how you log into your virtual machine and start changing the settings. In order to do that from my laptop to be connected over the internet, I would need to enable remote desktop protocol on the system, and it uses TCP port 3389. TCP is a little slower, but it does a handshake confirmation, right? And then the UDP port is the same. So when you're monitoring the network, you would see this coming up, right? Now, some administrator, they would use uncommon ports, however, right? But this is the common port number. And then I think my Raspberry Pi courses are available on my YouTube, but I use VNC sometimes. It's definitely not a secure way, but you can use VNC to access your Raspberry Pi instead of SSH. So one needs to be the host, the other one needs to be the server. So for example, my Raspberry Pi is a VNC server, so you just need to activate it. You turn that on. And then my laptop would then be the client, the VNC client. So just, it's free. It's a free application that you install, and it enable that service. And then you just need to, if you're on the local area network, you just need to make sure that you know the IP address of the other one to be connected, or you can also connect it by name. But the VNC system, it's really simple. You can go to their website. Real VNC is the product that you can use for VNC. When you're not using this remote desktop option, you can turn it off. Ideally, it should, because otherwise someone, again, can capitalize on that service, right? So VNC platform is independent, like I mentioned before, client server. So if you have a Raspberry Pi, if you want to tinker with this, you can set it up and see if you can connect to it with your computer, and see. And that's, practicing networking as well. Okay, so let's talk about how we can answer number one. How is Telnet used in the local area network, your LAN? Why shouldn't Telnet be used in the local area network? And what protocol should be used instead of Telnet? So Telnet gives you the bi-directional interactive text-oriented communication facility using the virtual terminal connection. So that means that we are connecting to it with the virtual, and everything is going to be in plain text. It is not encrypted, so it can be visible once they are connected. It is used for virtual terminal connections to network appliances. So if I need to connect to my switches, my routers, like we said, or even security appliance, we can do so. It should not be used in the local area network because it is not secure, as the communication is in plain text and it is visible on the network. So someone can scan you, right, to see the type of communication that you're sending and receiving, your text information. So your payload is highly visible. That's what I'm saying, right? And we already talked about how we would use network monitoring tool to see packets and packets payload. Your SSH is the protocol that we should use instead of Telnet, and it provides secured encrypted communication in the network. So in place of Telnet, we should allow or enable SSH, which uses port 22. Whereas Telnet uses port 23. So when you're looking at, so anybody can run a security vulnerability scanner like Nmap and be able to see what kind of ports that's being opened, or they can just scan your entire public network, right, to see what kind of communication you have. So we want to close out or disable the ports that we don't use, and we want to use secure protocol. For SSH, how can SSH be used in a client server architecture? What operating system typically include SSH for system communication? What version of SSH is used in Windows 10? So we can use SSH to connect the client to the server using port 22. There are two versions of your SSH. You can have version 1, SSH1, or SSH2. Now, I know most of you are in the cybersecurity program. You already know that when we have an upgrade in the version, usually, we would fix the problem for the prior version or update the prior version. So you need to look into the vulnerability of your current SSH version. So if your company is using SSH version 1, we want to see what kind of flaws. And the reason why we do that, and I just talk about this with my Thursday classes, you want to identify the flaws. Sometimes we cannot fix the flaw, but we would see how we would reduce the risk, right? If there are practices or things that we can do, like configuration or updates, things like that, that's going to help. But there are two different versions. And we would use applications that include remote command line, login, and remote command execution, but any network services can be secured with SSH. Now, is it 100% secure? Not necessarily, right? We know that it is secure enough to give us some protection because of time. Encryption, um, breaking encryption, it's just about resources and time. Sometimes that requires reverse engineering, sometimes that requires key capture, sometimes that requires, brute forcing for the key. So nothing is 100% secure. It's just gonna buying us some time. So if you're using Linux operating system, like if you're using Kali or if you're using Ubuntu, right? Or even other releases like Red Hat, SSH comes with it. You can also use SSH in Windows command prompt. Okay. So in Linux, we normally would do SSH in terminal, right? We would utilize that service using the command. So SSH in the terminal. And if you, like I said, if you have Raspberry Pi, it's a good one to practice. They're not that expensive. It's a small computer that's portable, and you can run Debian or Raspbian on it. Definitely, you can set it up as an onion router. You can do a lot of things to it, but you can also utilize SSH in it. And it runs Linux. And then you have OpenSSH that can be used for Windows OS. And so I think now with the later operating system for Microsoft, you see that it is a little bit more universal in the type of service. They're not doing proprietary services so much anymore because they realize that you have to make sure that it is universal so consumer can utilize it across multiple systems. So you're not required to, before that used to be the model to market the product. But now I think we have such a variety of different products and systems in the network. The vendor, the manufacturer, they have to understand that they're transitioning their design and engineering to that. Okay. All right. Any question with 1 or 2? Yes.
Copy and paste that from the notes. 1 and 2.
I don't recall though, so I think there's some information from the notes, but my videos will be available in case you want to go back and look at it. I think for the notes, let me see. Yeah, the notes just cover some of the general information, right? The questions really came from just like for knowledge, general knowledge about the protocol high and how security plays in. But if you need to go back and review, I will post the video. Yeah, there's some information on the versions here. So yeah, you need to summarize it. And then Windows 10 SSH. So the majority of it will be there for number 2. Okay, so let's talk about RDP. So number 3, it says Gabriella wants to connect her Windows 10 system to another Windows system using RDP. How can she accomplish this task? The reason why I pose this question is because we can learn so much about RDP, but if we don't know how to use it, right, it would not be effective. So Gabriella can open remote desktop connection by searching. Everything is searchable on your Windows search bar on the bottom. Searching for remote desktop connection. Okay, like right here. Then after she had gotten the result from her search, she will click the option from the drop-down menu, and then you need to enter the system IP address, the system that we're connecting to, that she's connecting to, right? The destination system IP. Or we can also use name. So we would have the computer name dot domain name. So such as computera.contoso.com. And then we have to have the authentication process. So you have to have the proper user account for the system that we're connecting to. And then we would connect. And this is the same process as we would connect to a cloud instance. But for the cloud instance, we would need the public IP. Okay, so if I want to connect to my Windows Server Cloud instance, I open up my RDP option, and then I would put in the public IP address. So when you spin up your instance and you publish it or you activate it, you make it go live, right? The service provider will give you a public IP. And that public IP is then being used to connect. Now, when I'm connecting to, for example, my Windows 10 laptop, connecting to my Windows server on my cloud, right? I put in the public IP and it's going to ask me for authentication, my user account. So I would log in, for example, as a user or an administrator, in the case that, usually they tell you that you only activate that account when you need to configure. So I would log in as an administrator, put in my passwords, everything validates, then would see the desktop of my Windows server. Okay, and that's how you connect. Now, you can do this with the free Azure account that they give you, the $100 free credit, and you can do the same thing with AWS. So once you're done, you need to take down your test server, or unless if it's go live, then it's publicly, but you got to make sure that you have proper protection on it. Okay, but you can also connect it with a name and domain name. So ideally, in a local area network, this works a little bit better. In the public network or over the internet, right, we would use the public IP address. In a local area network, you would use the private IP address. So if you do this at home, you would use the 192.168.x, right, your destination system. So if I'm connecting my desktop PC to my laptop, right, I would then use my laptop IP address for my desktop to be connecting to it. Okay. So that's how you do that. So when you get an interview questions, right, you're going for, a lot of the times they, IT support, if you go for that, or if you go for network support, they normally ask you, do you have any experience remote connecting to any system? And you should say, practice this. Yes, I use remote desktop protocol in Windows environment in Windows 10, connecting to another Windows system, and explain how, right? And then, but then sometimes they're interested in using like service desk, which is like a service ticketing system. And then within it, it has like tools and things that you can use to connect to various systems to do, or some of you use TeamViewer and other things. So those things is important to mention. Okay. All right. Any question? Okay. So RDP is there. Okay. For the book, it just gives you like description of the protocol, and so using the questions, I want to give you additional information. We've learned about HTTPS already. That's secure HTTP, hypertext transfer protocol. It does use SSL TLS socket. So that way you have encryption. So you can, now when you see the colon with the number like this, we know that that's a port number, right? So you can connect to a firewall using this public IP, let's say, and or the local area network IP, and then the port number. Now, if you want to transfer file, we can use FTP, but we should use secure FTP, SFTP, using SSH. And then you have TFTP, which is use port 21. Let's take this down. Yeah, there's a huge gap. Oh, sorry, bless you. So for number 4, it says Adam wants to use VNC to connect to your Windows PC to an Ubuntu system to control the Linux system, right? Describe the steps that Adam must take to establish the system connection. So I recommend that you visit realvnc.com, and you can go there to download the software that you need. So if I'm Adam, I'm on my Windows 10 and I need to connect to the Linux machine, which runs Ubuntu Linux, I would install VNC on both systems. Okay, you have to have the same product. So you would go and download, and there are instructions on the website, and it's open source, so you can use it. It works with Windows and Linux environment and other OS. So you would download and install VNC, and it's called VNC Viewer. Okay, so we need to do that for Windows 10, which is a client system. So the connecting system is going to be the client system, and the receiving system is going to be the server system. On the Ubuntu Linux system, use command line terminal to install OpenVNC. You can go to the website and download it for the version for the Linux, but you can, if you use the terminal, you guys already learned, right? Sudo apt install OpenVNC, or you can go to the website and look up instruction on how to install it on Linux, and it will walk you through it. So we would need to install OpenVNC features and access the server using commands, and these are the commands. Sudo apt install XFC4 goodies, so that's the package that you need. And then we would need to do sudo apt install tight VNC server. And then once you install it, you just activate it using, or execute it using the command. So once I install the tight VNC server, I do VNC server, right, to activate it. Then once we have that, we would locate our IP address. So locate the IP address of the Ubuntu system using IP address. And then on your Windows 10, open up your VNC application and connect to the Ubuntu, because when you open it up, it's going to give you the field to put in the IP address, and you just type in the destination address, which is the Ubuntu. So now you know how to do this. So if you want to test it on like a Raspberry Pi, you can, or if you have 2 computers, you can do that. You can set it up so that way you can remote desktop, right? Using VNC. And then, like I said, if you're not using it, turn it off, right? You can uninstall the packages if you don't want it any longer. You can turn off the service. I use this quite a bit for Raspberry Pi whenever I don't want to use SSH. So if I need to do a quick configuration on the Pi from my laptop, so when you connect, when you connect it, it's gonna open up the Raspberry Pi desktop on your screen, right? Like that's how we remote connect. We see what the other system has, bless you, on screen. So that's how you do that. Now, when they update the versions, so if they update the packages, they might rename the packages that you see there for VNC. So again, like I said, go back to the website, read the documentation on how to install, and be able to download and install it on your terminal or using your terminal. So the majority of your jobs is gonna be surrounded with remote desktop type of access. If you're threat hunting on a client system, if you are reconfiguring or changing firewall settings, if you are changing network connectivity, a lot of these things we do remotely, right? You don't want, this is why the IT job can be hybrid or can be remote. You can manage a lot of things remote, especially in a data center cloud environment, or, you know, so you can connect to it using different type of remote access protocol. Unless, you know, it crashed because of hardware level, then you have to go there, replace things and then make sure that you get it out. So if it's connected to the network, we can connect to it and configure, right? With the appropriate account access and services that's permitted. So the receiving system is going to be the server, the connecting system is going to be the client, and that's how you do VNC server client environment. Okay. I guess I can move things up a little. Okay, so the next section in your notes there, it talks about your out of band or in band for the modem. We I think in United States some of us still use modem, right? Like cable modem, DSL, in some remote area. But I think for a lot of they have upgraded infrastructure, so I think there's a lot of investments and grants from the government to be able to expand across all states for fiber networks. Okay. But what you see is for number 5, it asks you, how do you manage a modem that is out of band and cannot be connected via the network? Like it cannot be reached. Okay. You would use the auxiliary port to gain remote access to the device. You can connect to it using Telnet or SSH. Okay. So if you're managing and you do see cable modem being used for like transactional systems in the smaller business environment, if they're not on fiber networks. So in the case that it is out of band, you have an option to connect to it using the auxiliary port. Okay, before we answer the next one, I want to point out the section of the notes where you can find this information. You can find that answer in the out of band section right here. And then in the next bullet, it talks about public switch telephone network, which I think we move mostly away from. But there are part of the world that's still using PSTN. This was from, you know, the 20s all the way forward, and that transition to how they would route calls. So this is for the analog era. Um, and that would be using the pot. So when you see landline telephone line that was used back then, I think for the most part now we're using voice over IP for landline connection even. But public switch telephone network was, you know, your parents or your grandparents' days. Okay. And that was how people were able to connect to the internet, was to use dial-up, right? In the 80s and the 90s, and transition toward early 2000, I think we transitioned to more of a digital network where 3G started to be more popular and so on. So your PSTN section is here on page 2. It is analog, and analog signal is a wavelength, right? You have inconsistency in the signal. So sometimes when you're making a call, you might hear, you know, low volume, and then sometimes it's very clear. In the digital environment, which is what you see for the mobile networks and most of our landline connections, with the fiber infrastructure, everything is converted to 0 and 1s, right, before it gets sent out. So your telephone systems, in the voice over IP network, before it send that voice packet out, right, it digitizes it. It encapsulates and decapsulates at the same time. Okay. And so here it talks about that. And so I implemented, when I started doing network contracts, that was frame relays day, which is before ISDN and T1. So when this came, data transfer was tremendously faster. A lot of businesses was either buying tier 1 or tier 2, you know, and if you're looking back now, it's just a fraction of what you see in your regular home network, right? You know, it blows my mind on how, like, 20 years ago we were paying, and tier 1 is kind of like paying for your mobile package. It's data costs, similar to what you see with cloud. So if you transfer like certain amount of data, you have to buy certain tier. And then they also charge you for the amount of time that you're on it. It's like your grandparents used to say, oh, I used to pay for a long distance call. It was like that, right? We would pay for the amount of the data for transfer. So ISDN and tier 1 was the more of a legacy, and it uses point-to-point link through for the digital path. And this is when we start transitioning from the analog signal into the digital signal for most of the business environment. And then eventually that came with the consumer, for the household, and so on. But the dial-up back then, when I was growing up, right, we would wait for the internet connection with the dial tones, and it was 56 kilobit per second. And then eventually, you know, you got ISDN where you can still make phone calls and dial up with the cable modem. Which doubles that, so you're at 128 kilobit per second. And then eventually you get up to be 2 gigs. So now even this on the slow cable modem, you're at what? Tremendously more than that, right? 10, 20, or even higher. Okay. Here are the modem types. So you got the external and the internal modem. The external modem is a separate device. Basically, you have to buy the device. It's like a small box, and you attach it to your computer. The internal modem is an expansion card, like kind of like your video card or your sound card. You attach it to the motherboard, right? And then you install it onto the motherboard. So that was how that those devices were used. Now, I know Network Plus sometimes asks legacy questions because you might run into old systems when you troubleshoot. So the type of modems that are used to connect to your remote network using PSTN lines anytime that you're dealing with analog, you would use a modem. And you would have external modem, like I said, which is a device that you connect to the computer. It's a box, an outside box. And then you have an internal modem, which is an expansion card that you have to open up the computer case, right? And be able to attach it to the motherboard onto the bus, which is a slot on the motherboard. And you would connect a cable to it. So it would use a coaxial, right? Sometime the older modem also used telephone line. Cable modem would have multiple media connections, so you might be able to adapt different cables to it. But likely you will have a telephone line, which uses RJ11, the smaller connector compared to your Ethernet connector. Any question? And you can find this on the notes, and if you want to clip that from there, question, you can. Maybe it's the dust in this room causes allergies, or the vent.
You're just sneezing because someone's talking about you.
Okay, so you can find that here. And then your ISDN, it stands for Integrated Services Digital Network, and this is an upgrade, right, from your public telephone network. So ISDN uses channels. Now United States and Japan different and you see that in communication on how different part of the world, different continent uses also different type of communication. So for the circuits, it uses data channels, and mostly we would look at channel B and D. So there are 2 channels on B and 1 channel on D. So B is used to do data transfer. So you're at 64 kilobit per second. This is called the bear. And then the D channel, it's for signal. So they go together, right? So that's 16 kilobit per second or 64 kilobit per second. Okay. So in order to use it, your channel D enable your channel B to pass data. Okay. And channel D is used to for administrative overhead of the channel B. So your bandwidth is a combine of those 2. Because back then, if you're using analog phone, right? When you're dialing up to the internet, nobody can make phone call, right? And then we came out with dual channel, and people are able to transmit data and make phone call at the same time. So that was definitely an improvement. And then I'm sure you've seen this in the earlier chapter. They talk about BRI and PRI. Now, if you are coupling or using multiple B channel, you can also, that's called channel H, and channel H is 6 of the B channel. So later on, we're able to group up the channels and then be able to implement that for faster data transfer. So Network Plus is the harder certification because it asks you these things. It asks you about RAS, it asks you about the acronyms, it asks you about these channels. So make sure that we look through them, even though technology like this might not be around for most of you when you're entering the field or when you're working now, right? But there are part of the world that still use this, so we have to know. And communication technology is the current technology is an improvement of the prior technology. So you have to know your legacy system to better understand your current system, right? That's how IT work is. We are an innovative engine. We are always building on the foundational knowledge and then improving. Okay. And then your BRI rates, it talks about that here compared to your PRI, which is simply, different groupings of your channels. Okay, let's go through the questions. I'm going to move 6 down to the next page so you can see. Okay, so this,
Still need D. For your,
you still need D on number 4? Okay. Sorry. All right, for number 7, it says describe the channels used in ISDN for voice and or data. How many B channels can be used for, or 2, 1 point, use 4, that should be. For 1.5 megabit per second on 11 or H11 in an ISDN network. Okay. So we know that B channel is used for data transfer. Each of the channel is 64 kilobit per second. You just have to do the math. The D channel, it is for signal, and it is 16 or 64 kilobit per second. And you can clip this from your notes, so you don't have to type, but if you wish to type, you can. The D channel enables the B channel to pass data, and the D channel is used to remove the overhead for the administrative channel. B. So with that understanding, the bandwidth for the D channel would be depending on the service. So they would select 2 types, right? One of the 2 is going to be the BRI, which is 16 kilobit per second. Of course, when you're transferring slower, right, you're paying a lower rate. And then for your PRI, that will be 64 kilobit per second. So in order to achieve 1.5 megabit per second, you simply group up your B channel, which transfer at 64 kilobit per second. So if you convert 1.5 megabit per second to kilobytes or kilobit per second, and then you divide that by 64 kilobit per second, you will get the number of your channels. Okay. So I simply need to do unit conversion here. Okay. So 1.5 megabit per second, convert that to how many kilobit per second, right? And then we simply multiply, because you're going from kilo to mega, right? And then you have that number, you would take that divided by 64 kilobit per second, and you would have 24 channels. And that's going to be the requirement number of channels to transfer your data at 1.5 megabit per second. So the network engineers back then, they have to determine, right, how much data or how many channels do we need to be able to transfer, right, at most at this data rate. So if you guys complaining sometimes your internet at home is slow, imagine back then, right? 1.5 megabit per second, that's slow. So when you're downloading a file, it just takes longer to get like a video or you know, a song, like an MP3, or even, you know, getting your email open, things like that. And if imagine if this is shared across the network, right? So 1.5 megabit per second is not just like for one or two systems, it's for hundreds of systems that's sharing that bandwidth. So we were forced to do a lot of quality of service, right? Priority stuff like the server stuff is gonna get the priority of the bandwidth, and then all the user access and you know, some of the smaller application, the web application stuff is gonna be slower. So, you know, but back then you don't have a lot of web resources like what you see now, right? You see now is close to real time is because we have the technology and the capability, the connection to back it up. So. And then even if you're connecting from a network with that speed, and then the server that's giving you the files is maybe even slower. So you will get throttle either way, right? So sometimes you would get, like, for example, if I'm going to a website to download a song, and that server is performing way low than this, even if I'm connecting with that, right? The file is coming to me at a slower rate either way. Okay, any question regarding 7? Okay. Okay, so now we want to be able to calculate the B and the D channels that would be used for PRI, or primary rate interface, to derive 1.5 megabit per second or higher transmission for US and Europe. So in the US, we would need 23 B channels plus one 64 kilobit per second D channel. Okay, so when I'm using B channel, they are already at 64 kilobit per second. You take 64 kbps, times it by 23, and then you need one of the D, right? That's for signal. That will be used for PRI to yield 1.5 megabit per second transmission rate. In Europe, like I mentioned before, that will be different. So we're going to be slightly higher, or yeah, slightly higher than your 1.5. So we would need 30 B channels and one 64 kilobit per second D channel for signal. And that's going to give you like right above 1.5. So 1984 kilobits per second. It's just the communication for Europe, their requirement for the channel is just higher. So that's why you see that. And, you know, there's also different in Asia, like Japan, which was one of the countries that have that implemented first. So when you get the PRI questions and the BRI questions, that's how that number can be calculated. By grouping the channels and summing them up, adding that with the D channel, and that's the total transfer rate you're gonna get. Bless you. Okay, so you might see job description that would require you to be able to maintain and support, right, remote access services, remote access servers, your RRAS or your RAS. So remote access traditionally was remote access traditionally was really designed from the telephone era and integrated into what we see in the digital network today. So when you're looking at the software tools for the configuration for remote access, like in Windows Server, when you install that role and you configure that role, you still see that it's gonna have that dial-up option, right? Yeah, because somewhere in the world there might still be systems that are connecting through dial-up. However, right, from the legacy into the newer environment, you always want to make sure that people can roll back or upgrade, right? But so what you see is the protocols that were implemented for remote access. This, what we see is traditionally using serial line internet protocol. And when you hear the word serial, you already know it's going to be like 1 bit at a time, right? And then when that transitioned to something in the digital era, what you see is they implemented point-to-point protocol. So when you look at server configuration, you would see the options. Is it telephone, which uses serial, right? Or is it going to be point-to-point, right? So it's basically it's connecting system to system. And PPP been around for a long time. Many different type of network system uses PPP. And then you have PPTP. And with that, we would see that the protocols back then was upgraded to use cable modem or modem connection instead of using telephone line and dial-up modem. Okay. So BRI, TR information here. And then I put some description so you can look through that, and it talks about data link and how to use devices with ISDN. You would rarely see jobs that require this now, right? We have upgraded our network systems, but in the case that if they do use this as a backup, right, you would have to be able to maintain it. Not install it, but maintain it. So that's why, like, in security, whenever that we see landline or telephone connection for a backup line, that's a vulnerability issue. So wanted to be able to integrate. And then your remote access information is here, SLIP, PPP. And then your network control protocol, your NCP. And it goes into the functionality, the components of PPP. So for number 10, when using PPP in remote access service, what protocols can be used for authentication? Traditionally, we would use PAP. This was used for client authentication to the server by passing username and password, so that way the server can compare for a match. So the server compares the credential to the stored information, so you have to have that account already created on the server. And then when the client connects, it's just going to try to match up to see if the information is comparable. So that means that the system opens listening devices for such as network sniff. So if I want to capture your credential, I can sniff that out. So PAP was not secure. Then we upgraded to CHAP, which is CHAP. CHAP uses encryption algorithm that passes authentication data to prevent hackers from sniffing it, right? So it was an upgrade from PAP to CHAP, where it uses encryption algorithm as it passes the information for comparison. Then Microsoft implemented MS Chat, and there are different versions of this. It uses the same type of encryption as chat, but more secure using hash challenge for session and password. And password is encrypted when stored. But we know that whenever we store something, our system create a hash, right? So, like I said, not 100% secure, but it was something that was better than before. So those were the protocols that were used in point-to-point remote access service environment. So if you select this option on your server configuration, you have to follow it up with the authentication type, right? And for Windows environment, you would select like, MS Chat version, etc. And then Kerberos is an integration later on in the Windows network, but it's that it's not 100% Windows. You can use it with other platform. So Kerberos is a mutual authentication protocol. We use this for authenticating to the server between for the client to authenticate to the server. And it requires a TGC, a ticket granting center, or a role that would grant the ticket for the client to access the server at a certain amount of time. And the way that I remember Kerberos, it's like going into a circus, or a theme park. You need to have some form of ticket. So you have to set up a feature for the system to grant the service or the ticket to the client. It's another way to confirm, right, that authentication is going to be mutually agreed between the systems. I think golden tickets was a attack like long ago that someone came up with, but security is about buying time. So I think that some of you are familiar with this. If you ever look for modem packages, you've probably seen this. Maybe 10 years ago, it was a lot more popular than it is now. If you live in remote areas where you cannot get fiber optic, you're still relying on satellite and most of the time cable modem. You would have to choose something that will be adequate for your network. Okay. So there, I mentioned this before, but we would see ADSL and SDSL. So for the A, that will be your asynchronous, where your data is sent separately, relying on the mode from each end to transfer the bit order. And when you have asynchronous, you would see that your download rate and your upload rate are different. Right? They are different because they are independent. They're separate. Any question? And then we'll touch on synchronous. Can I move 11 down to the next page now? Are we okay with 10 already?
Fill up by
Are you on the last bullet?
1 second.
Okay. I'll leave it there for a little bit and then we'll move. So next week, I think some of you didn't get here from earlier, or didn't hear what I said earlier. Next week, no school. Our campus is closed for the holidays. No class in session the whole week. Okay, so you should have a good Thanksgiving week off. For this class, the first week of December is going to be like the final review week. I don't require attendance that week. There's still like one chapter. I will probably post a video for it. So that way, if you want to look at the notes and that, we were a little bit behind because of the holidays and I was sick one week and that kind of threw everything off. But final exam will be activated the second week of December on Canvas. You will need to use Lockdown Browser to access it. However, I will be here the first week of December for those of you who want to still trying to square away things, but try to get everything submitted by the 1st or by the end of Thanksgiving week. So that way I can update your grade going into the finals, but in the case something happens, send me an email. And then I do not allow late final because I do open the final from Monday through Thursday, which is the whole entire week, right? We close our classes Thursday at 11:59 for all online classes, all regular classes. Except for if the class starts Friday, then they close on Friday. But right, and then a few days after that, your grade should be finalized. But I will send you a notification via Canvas message that when your grade goes up to WebAdvisor. And then shortly after that, I will issue you a badge for the course, and you just need to click your email link to claim your digital badge. And then you can link that to your social media account to promote career development purposes, right? All right, let's move 11 down now. We're good, right? To the next page in case we're still looking at those. And then let's move this up. We only have a few more to go. Okay, so 413, it asks you to identify the requirements for remote access. So if I want to set up remote access for my network, what kind of things do I need to check for? The client, which is the connecting system, needs to be set up with some kind of public IP, a dial-up number of the remote access server, right? So on the server, I need to set that up. We need to also enable a certain protocol, like what we have talked about, and authentication information, an account access. Then we need to have a server. So your remote access server needs to be readily available. So it needs to enable access on the remote network. Now the user account, it would have to use point-to-point-to-point, SLIP, or RAS. That means that they have to have the valid ID and password on the remote server. So you have to create this on the server itself or on the network that's been granted for dial-up permission. So if you're using the traditional old school way, right, you have to set up the dial-up permission for that system with a phone number that's appropriate. So that just means that they dial that number every time that they need to connect to your server, and they need to validate like their access information. For the remote access on the newer environment, what you would need is you still need to configure your server. You still have to specify the protocol, right, that you use and the authentication methods that you need. But you have to have the account and then you can also set up how it's routed in as well. Now, on the newer system, like if you're using modem or ISDN, you need to have the device that is connected with your remote system. On the dial-up client, you need to have a modem, which is a dial-up modem, and the server needs to have another modem. So both of these devices needs to be connected somehow. So they need to be connected via the modem. Then for your access protocol, basically this is your protocol that needs to be configured for access resources like we talked about, chat, MS chat, PAP. Those things needs to be configured. Oh, did I talk about synchronous? Maybe I forgot earlier. But synchronous means together, and data are sent together at one clock signal. But for the 13, the last bullet, it mentioned access protocol. So we would need to set that up for your remote access, and that will be configured on the server. So those are the things that you need to establish your remote access. Now, most of your devices today is connecting to your network, right? And then maybe use a virtual private network to connect to your remote server. So we would need to have public IP information. Now, what you see is the newer protocol that's integrated for connectivity that's going to allow us to integrate or to implement VPN or virtual private network. And virtual private network can come in many types, right? Or different types, I should say. So your PBTP provides a secure transfer of data from your remote client to your server. And it's using multiple protocol with the VPN. The benefits of this is that it uses encryption and your transmission is secure. You can integrate this with your current TCP/IP network, which is a huge upgrade from the alternative of your conventional dial-up networking methods. That's the old way. And when you enable multiple protocol for secure communication with your TCP IP public network, which you use a public IP address, right? You have to enable multiple protocol. Your service level is going to be enhanced with security. And VPNs are used to provide tunneling through public network with secure communication. You can find this on your notes too, right? And why is it perfect for VPN? It uses generic routing encapsulation protocol, which transfer PPP packet. So ultimately, it is encapsulated for the transfer of your traditional PPP packets. Sorry.
We bring down to 13.
I can't pull it down all the way because so we can come back to that. Okay, how about that in a little bit? Is it such long? Maybe I can zoom out.
Use the second bullet point.
Yeah, then it will cut off for everybody. So can you come back to that? Just highlight that section and then you can come back to that. You know, just add to it later on. That's what I mean. So you can put on the other bullets and just leave that space blank and then just add on later. Or you can go back to your notes and then be able to pull that information. It doesn't have to be verbatim. The whole point in this is to help you guys review, right? A lot of this is very much detailed into the protocol. So the third bullets. And you have my video, so you can always go back on YouTube and then scroll back to the section when you need. We can look it over again. So if we're using tunneling, right, PPTP, you need a public IP. So when you set up remote access server, you select that role for your Windows Server 2019. As you go through the wizard, it's at one point, it's going to prompt you that. It's going to prompt you public IP information for routing purposes. And then also, if you want to add the VPN with that, you would select the feature and the role for that type of service. Okay, so in this section now, we're going to talk about virtual private network, right? Virtual private network is a way that we can connect to a network virtually, like it's a connectivity that we can then eventually connect to our remote access system. So the type of encryption that you see with OpenVPN,
You bring it down.
hold on a second. I'm trying to see if it's the same. So for OpenVPN, you would see that the authentication that would be used is it uses AES 256-bit key. So that's your key length is 256-bit. And then your encryption would be 2048-bit with our RSA encryption. And the hash algorithm is going to be SHA or SHA version 1. And it is 160-bit. So when you're looking at encryption technology, especially for authentication, you would, number one, look at your key length. And in this case, it is AES 256-bit. That's the algorithm. Then you have RSA 2048. That's the length of your encryption. And also your hash algorithm, which is SHA SHA version 1, 160-bit. So the benefit is that it is strong, but the disadvantage is that it's going to be slow. So you are always going to have that performance versus security, right? When you deal with encryption, if you want a strong encryption, right, the longer length encryption with strong key, with good algorithm, the risk is going to be the performance. Yeah, I just went over blockchain with my Thursday class last week or the week before when we talk about encryption.
Lots of that.
It's 41D, Advanced Security Practices. Yeah, that's the CASP class, the CAS plus certification. Yeah, so it gets a little bit closer to, you know, what you see with cryptocurrency and how that's used and going into blockchain and but ultimately you're gonna be implementing, you know, either chunk or bit, and then if it's chaining the block, so you're gonna see that it's gonna be slower with blockchain anyway. Okay. So when you set up VPN, for example, in Windows Server 2019, you're going to be presented with options like, do you want to use L2TP? Do you want to set up IP security or IPsec? So what you see is that for the L2TP or IPsec VPN strength for algorithm is that it still uses AES. The majority of your technology is going to use this algorithm that you see, including wireless, right? So 256-bit encryption. And AES is the one that we prefer for most of, from mobile devices to wireless devices to, I'm sorry, to your server configuration. That's the preferred. It is slower than if you're using like an older technology. Okay. Maybe I can disable caption. So in comparison to your tunnel protocol or point-to-point tunneling protocol, it is going to be more slower, right? It does use specific fixed ports. Um, there's some blockage issues from L2TP to PPTP. But what you see is that it is a very well or common option for virtual private networks. So a lot of people recommend, right, using IPsec or L2TP. I think more IPsec is preferred these days because it does do the tunneling as well. Any question? And you don't have to add the last bullet, but you just need to know that the reason why it's preferred is because it does give you good connection speed. But because it uses UDP on a single port, it can be easily blocked. Have the Okay, I think we only have a few more. So if you missed something, we can come back to that section. I do need to proceed so that way I can, some of you can, I know all of you want to work on your lab so you can get home, but we also need a break, right? Okay, so what I'll do is I'll move 15 and 16 to the next page so we can still see that. And then I'll come back to this section if you miss something. Okay, so the difference between using SSH and a VPN is that SSH allows you to connect to a system like a router, a switch, a computer, where a VPN, a virtual private network, allows you to connect to a network, a group of systems. Okay. So if I need to connect my laptop to a security appliance, right, like FortiGate, I can use SSH. But if I need to connect to my company's network, I would need to use a virtual private network connection, a VPN. And so we do see that there are a variety of options that the consumer are presented with or people are using. But for organization, they can set up what you see is site-to-site VPN. Is a way that we can connect multiple networks together. So for example, I can connect headquarter office or headquarter network with the regional branches together using site-to-site VPN. So what they can do is they can combine the networks into one virtual private network, right? Because you know that logically, the geolocation, you have to set up that as individual subnetwork to your larger network. So in order to combine my national networks, right? Let's say of all my retail stores to my corporate office, I need to use something like site-to-site VPN. But you can capitalize on that using site-to-site VPN as a way to combine your bandwidth. So that way you would have more of a higher bandwidth for your private network. And your site-to-site VPN is often preferred by the company, especially if they are national company or they spread across the regions. When you're looking at corporate entity or national chain for retailers or branches in different cities, the option would be ideal to do site-to-site VPN. That means that we have one location to the next location to the third location and so on. That means it's site-to-site. Any question? Now, you don't have to have a server box, right, with the server OS to configure VPNs. As you look at the lab today, you can buy appliances that has VPN features. So you can have a dedicated device specifically for VPN, or you can use a security appliance that has VPN feature and you can configure that. Now, when we're looking at a single point device for VPN, right, or a server, an appliance, we look at that as a single point failure. So you got to make sure that when you establish VPN, you don't have a single point failure. That means that you don't rely on one single point just for that service. You got to make sure that you have redundancy. And then let's move up 19 so we can see more of that. So it says, when is remote access VPN used? What type of VPN protocol should be used for remote access VPN? So if you need to establish a temporary connection between the two subnetworks, right, like your corporate office to another regional office, then you can use remote access VPN. So the example here, I put down that we want to connect the users at the headquarters to the data center applications. We can establish the remote access VPN, but temporarily. And we should use IP security or IPsec. That should be a capital S, I'm sorry. But you often see that they would set up SSL VPN, which is a web-based, right? So when you're buying a commercial VPN product, like let's say I pay $10 a month for my VPN, or if my VPN comes with my security software that uses a web application, likely that you see that it is an SSL VPN. So I get a lot of questions from people who attend like my workshops and things about cybersecurity. And they always ask about, should I use a VPN? That's a definite yes. Especially if you're connecting to a lot of the public network. You shouldn't, but and then what kind of VPN products that I should buy. There's not a true correct answer for this, right? It really, you have to look at factors like, performance, the type, what can you afford, that kind of things. But a lot of the product that you see in the market is SSL based VPN. Okay. And so with that, we would be able to set up the user connection to the gateway, which is normally you have to authenticate to it. Some network admin would use, or security admin, they would set up a firewall. Outside your external firewall is going to be your VPN gateway, or sometime that could be your router. And it has to bring you into the network ultimately. Right? And you see this with organization as well. Okay. Any question with this? And then, is it the last one? Yeah. Lastly, for 20, describe how teleworkers or remote workers, we should say, business travelers can use client-to-site VPN connection to securely access company application remotely. They would use host-to-host IPsec connection, IP security connection, which is an encrypted connection between two systems. They both need to have IP security services be available. So that means that they have to have that enabled and running with the same authentication key. So with the IP security connection active, any network traffic between the hosts is encrypted. So that way, if I'm traveling, I'm still able to do some work, right? Let's say I travel for work, I'm still able to do that in the meantime, as long as I have that secure connection. So it is host-to-host based. That means that the system that I'm connecting to, it needs to have the IP security enabled, and my system needs to have IP security service enabled. So that way we can establish that tunnel connection for the encryption, for encrypted transmission for my data. Because I think a lot of times people say, oh, use IP security, but this is what's really in the background for VPN when you break it down to how systems should be logically connected. It's system to system, and they are running the services. So it brings back to what? Earlier we talked about point to point, so it's still, right, logically set up to be point to point connected, you see? So are we far from the traditional ways? Not so much. We're just transferring things quicker, communicating faster because we have the medium to do so. On our cable is transmitting faster. Our network is designed a little bit more efficient, but ultimately it's still, some aspect of it is still based on the traditional structure of VPN. Okay. Any question? I will stop the video. And then if you miss a section, we can go up.